It's good afternoon, students. Today class we're going to discuss about the software testing topics. So last classes we discussed about the characteristics of the software creations and design implementations. Now we're going to study about the software testing. It's welcome to the software testing classes. So up to now we study about the software constructions and what are the coding standards and coding methods and several review techniques and all we discussed. Today class we're going to see about the software testing. So I will start with the what is software testing, and then we study about the error, mistakes, fault, that and all we're going to study. Okay, software testing. This is a fourth level. First requirement gathering, then design, then construction, then we come to the testing. So what is the error first? So we can call that is a fault. Okay, fault is the it's a maybe the human error or mistakes. Okay, so sometimes it leads to the defects of our product. So when we can call it the failure. So when the software product we are created and that won't give the expected outcome means, then we can call that is the failure one. Okay, so this is the difference between the fault and failure. Okay, so error means some mistakes, and fault means uh, we are doing some defect or getting the defect in the product, and failure means total outcome is we won't get. That is the failure. So now previous days, the software testing, how they did the testing means they did all the four levels like requirement gathering, design part, coding part. Then only we come to the testing. So after this four level of work, then we started testing means if we are did the fault in the requirement gathering place itself means then the outcome will be the error. So we are having the input is error. With this input error, we are starting our work and completing the software product. So completely it will be give the wrong output. Okay. So the previous olden days or traditional software methodology, the software testing we done in the last level only. So that if it is any error in the any initial levels like a design level or the requirement gathering level or the construction level, if it is error means then we are missing to check the part in the initial time itself. So it's lead to the complete product will be the failure one. So the strategic approach we are following for software testing is we have to take some plan in advance to conduct the systematic testing at each level. So we have to take the number of software testing strategies. So several methods are available, like validation testing, system testing, alpha beta testing, black box, white box testing, some like that. Testing methodologies are there. We have to apply the several strategies of testing. So all these testing having methodology having the some characteristics. They have to perform effective testing like review. What is review? I told in the previous class. So reviews means we do the inspection or walkthrough. These are the methodology of reviews. That's like calling some persons or external persons and team persons to check our product to find out the error, and suggestions will be taken by the developer, and changes will be done by the developer accordingly. So like that, we have to take the several review methodology, and testing begins at the every component level. That is, you can call it unit testing. We'll see it in next future classes. So then different testing techniques are appropriate for the different software engineering approaches, and testing conducted by the developer only. Okay, there is not a separate persons are available. Developer only doing the testing also. So testing and debugging are the two different activities. And next, two important definitions about the software verification and validation. Okay, so verification and validation we're going to discuss. Verification means what is the verification? Verification, um, every functions it will be work properly means that is called the verification. Okay, so for purpose of the seeing individual functional functions, for example, in the medical software we are preparing the bill is one of the function. New items we add into the software, that is another function. Expiry items we need to remove, that is another function. Like that, every functions individually we check means that is called the verification. What is validation? Validation means are the product we developed is correct or not. Okay, so we developed the whole software. Finally, we can check the software means that is called the validation. Okay, so people checking the validation whether the product is working properly or not. That is called the software validation. Okay, so now some of the strategy we can follow. So I depict given the figure, it depicts the some strategy. So what is the strategy here? Here, um, we discussed the four stages, no? Requirement gathering, design, coding, testing part. So these parts is parallel to our some several testing methods. Okay, the spiral. What is spiral? In depth, we can take one by one level. Okay, so the design part means that, so for example, requirement gathering part means individual part. Okay, so for code, first we can start with the code, that is core. Individual function code we check now, that is called unit testing. The design level we can check the integration testing. And requirement level, that is requirements we are satisfied or not, we are checking, that is called the validation testing. Finally, full requirements we done or not, that is called the system testing, whole system testing. So each level of the phases will be done, will be do with the some kind of the testing, like unit testing, integration testing, validation testing, and system testing. The strategy for the software testing viewed in the context of spiral only. So it's a moving outward. Okay, so unit, then integration, then validation, then system testing. Okay, so moving outward, the spiral will be moved. I list out the four testing: unit testing, integration testing, validation testing, system testing. So considering the process from the procedural point of view, starting with the code test, that is called unit test. So in the units are combining means that is called the integration testing, then validation testing, then system testing. First, this class I'm going to discuss about unit testing. Okay, next class for the remaining testing methodology will be discussed. So unit testing, so many strategic approaches are there for to complete this unit testing, or this one kind of the testing method, unit testing. System fully constructed and then tested means we will definitely get the faulty outcome only. Okay, why? Because we are not testing the every level. We're going to check our system working or not properly. We are testing in the final level only. Okay, so that we will check, suppose system fault happened during the design part itself means we missed to check in that level. So finally only we, after preparing the software only, we are finding this kind of the problem means, then the human effort we spending and time we are spending is all wasted. Okay, so this is a drawbacks to do the testing in the last. That's our previous traditional methodology. Now agile, we are doing the testing in the every step. Okay, every sprint we are doing the testing, or every phases we are doing the testing. This and all we take it in the agile process only, in agile method. So the solution for to avoiding the whole system failure, we can do the testing in the incremental view of point. Okay, incremental view of testing will be do it. So beginning the test at the individual program by unit wise. Every unit we will start the testing. So units are designated to facilitate the integration of units and culminate with test that exercise constructed system. Unit testing is the internal processing logic and data structures. So every parts we going to do the test. For I given the some example here. For the example, module we are doing the test. Module interface we testing. That is a front end we can test. Then local data structures are examined. That is a different testing. Then another unit, all independent paths through control structures are exercised. That is a testing. Then boundary conditions are tested. Then all error handling paths are tested. So this is just an example I am saying. So this is a five different kind of testing I am doing. Okay. One interface I am doing, the internal data structures, the variables are declared properly or like that I am checking, and all independent paths are I am checking for control statements execution, and boundary conditions I am checking, and all the error handlings are I am checking. Okay, so this kind of the all fives are checking. So the all individually checking. There is no relevant between or among these kind of these modules. This individual testing I happened. Finally, I can do the combine of this testing. I will do it in the next level, the integration testing. Okay. Now just understand, unit testing is the verification effort in the smallest unit of the software design. For every software design, we are going to do the testing. So procedure. So what is the procedure here? Design of unit test is before coding begins or after source code has been generated. So unit testing will be do before code or after code. So component is not a standalone program. Here we are using the driver and stub software. What is driver? The main program, or from where we are calling the program, function calling. There we can call it as the driver, and stubs are the individual unit, we can call it as the stub. Okay, so every units we are tested now, so that module will be replaced by stub. Okay, so stub is nothing but sub programs. Stubs plays the vital role in the unit testing. Okay, so what is stub? Every unit or every module we are going to test now, that is stub. Okay, after testing that stub, then so after testing that module, it will be replaced by the stub. Okay, and driver will be play the vital role in the integration testing that I will discuss next. So next in integration testing. So main purpose of integration testing is to properly do the interfacing, okay, among the modules. That is the integration testing purpose. So this is a systematic technique for the construction of software architecture. The objective is to take unit tested components and build a program structure. So incremental integration, we need to connect every module. Finally, we can get the combined module. Okay, so different integration strategies are available. Hope you understand what is integration testing. Integration testing means combine. Already we tested the units, no? So now every units, for example, A is one of the unit. For example, square root function calculation. B is another unit, that's a sum calculation. C is another unit, that is a multiplication calculation. All these three needs for your calculator program. Okay, just example only. I have the three functions are there. So these three separate units are individually tested. Now we need the calculator program, combined program we needed. In the calc, it should be contain the three things. Square root, sum, and multiplication. So all the three things will be incorporated into the single program, that is called the whole project. So that is whole project means. So now these three module we already tested in the unit testing. Now these three modules going to combine. That is called the integration testing. After these three combine, whether these three working properly or not in the calc. Okay, that is called integration testing. Okay, combinedly we are doing the testing. So now different kind of incremental testings are there. I list out here: top-down integration, bottom-up integration, regression testing, and smoke testing. So top-down integration, name itself we have meaning from the top to bottom in the vertical level. We are doing the testing, and bottom-up, from the bottom to top we are going to combine the model and do the testing. Regression testing means after we done this kind of the integration, whether the paths are working properly or not, whether it's getting the input or properly or not, or passing the input or not, after connecting the units, I'm saying. So that testing is called as regression testing. And smoke testing means we are smoking individual area. Okay, all the inputs, whether this path is getting the variable x or not, is producing the output y or not, like that. Every path we are checking, that is called the smoke testing. It may be do in the daily manner also. That is why smoking the people are doing daily. That is why the name is called the smoke testing. So in the diagram, I mentioning the top-down integration approach, integration testing I mentioned here. One of the type. First one is the top-down integration. Here we can do the integration in the two types. One is the depth first integration, second one is the breadth first integration. So the depth first integration will do the integrating, there's a connecting every module, module by module, from top to bottom in the vertical manner. Okay, so for